Hi, everybody. I'm just getting ready to tape our second class together. So, we started by talking a little bit about some of the practices for your homework. You had a homework assignment of graphing linear functions, which was a worksheet. And we went over some of the things that I want you to remember about the best way, the best use in this case, of your homework. Try every question. Don't leave any questions out. I'll be careful about what I assign to you and I won't give you extras. So, what I give to you is important for you to try. Make sure you correct your work. Now, there are a couple of ways you can do that. If I feel that the solutions at the back of the textbook are not detailed enough, then I will include a PDF on our site. So, the Google Classroom site, I'll include a solutions page. If there's not one, then that means that the textbook is fine. And so, what I want you to do is to use the back of the textbook to correct your work. Make sure these last two things are really important. Circle the questions that you need to ask about. So if something doesn't make sense, you've made a mistake and you can't figure out what it is, you don't understand how to do it, please circle it and bring it to class the next day. And then when we're working on it in class and we go over these things, make sure that you make notes about the things that you didn't understand because you're really trying to find those bits and pieces where you're not naturally understanding what's going on. So you're trying to basically program your brain. Your brain is not a computer, but when you learn, there's a similarity to what it is as to what we do when we're programming a computer. So, what you're looking for are the holes, are the places that you don't understand. And so, those things are so important to you learning and being successful. So, these last two things, circling the questions and asking about them, making sure you understand and make notes about those questions that gave you trouble. And those will be the ones, by the way, that you will study later. You're going to be handing your homework in each day, so make sure it's done on a separate piece of paper. And when I give it back to you in the next class, after I've had a quick look and made sure that you've completed it, then you'll be storing it in your binder. And you should have three sections in your binder: one for homework, one for assessments, and one for concept maps. Okay, so that was your homework assignment, and we took some time to take a look at the actual assignment together. So now we're going into our new lesson. Make sure that you have your notebook handy and that you're writing down this title. This is Unit 1, Systems of Linear Inequalities, and we're looking in particular at 6.1, Graphing Linear Inequalities. The goal of what we're trying to accomplish in this particular lesson is to understand linear inequalities well enough that you'll be able to use them to solve problems. So it started by giving you the following diagram and said, here you have a graph, and we have graphed y is equal to x on this graph. Now, if we consider this equation, y is equal to x, as a boundary line, up something that is dividing this particular coordinate plane into two regions. You have the triangle on top and the triangle on the bottom. So if this is the boundary line using that equation, then where would we actually shade to be able to show that y is less than or equal to this boundary line x? So we take a look at it, and there are different ways of seeing it, but I think the easiest is to specifically look at the y values. Here you have the y values running up and down, and here's your boundary line. If I look at the y values on this part, I know that the y values up here are higher or greater than this boundary line. If I look at the y values down here, I know that they are less than the boundary line. So for the first one, where they're asking us for y less than or equal to x, we would be looking at shading in the bottom part. And what this means is really important. It means that all of these points, all of the different pixels that fill in and make all of this shaded area, it could be 3, -1, or it could be 1.5 and a half, negative a half. All these little points satisfy that inequality of y less than or equal to x. If we turn it around and try to figure out, okay, well, where is y greater than or equal to the line called x? Well, for this one, it would be the triangle that is on top. So the next thing we looked at is, okay, well, what if we're wanting to graph something and we're not using an equal sign anymore? It's simply y is greater than x and y is less than x. Please notice in the diagrams you're going to see this is y is greater than x, this is y is less than x, and the only difference is that we're using a dotted line now for the boundary line because it's not equal to the boundary line, and so to be able to show that, we use the dotted line. Now, it can be confusing at first choosing a point which lies in the correct region. So, one of the hints that they suggest is just choose an easy point and experiment to see if your instinct or your first choice is actually correct or not. So, we're going to give it a try. This was the first example we did in class. And so, we have to do a couple things. We're going to have to rearrange this so that we can figure out where the y-intercept is and where the slope is. And we'll draw our graph and we'll see where we go from there. So here's the first part where I'm rearranging the graph. Now I moved the 4x over to the other side. That's why it's negative. Now, something important is happening right here. In order to get the y by itself, I have to divide by -5. And if I divide an inequality by a negative, then the sign has to change, has to flip. So once I go through and divide by -5, I get the following solution. So I have a y-intercept of -4. I'm going to go up 4 and over 5 to get my next point. Now, before I draw it, I take a second look and I realize, okay, this is not equal to this line. And so I'm going to use a dotted line. And then they want me to choose all of the y values, every single one that would be greater than this line. And sure enough, the y values are going to be greater on this upper region in this zone. So now to try it, especially in the beginning, until you get confident with it, I'm going to try 0, 0. 0, 0, of course, is right here. Now, it's in the region. So hopefully when I put in 0, 0, I will get something that is true. So I put in a 0 here and a 0 there. I get 0 is greater than 0 minus 4. And then when I look at that, 0 is greater than -4. Yeah, that's definitely true. So I've tested an easy point like 0, 0, and it's come out to show that, yep, my work is correct. All right, so we did the next one. And I would encourage you as you're going through these videos to just pause and give it a try yourself. With this one, we're going to have to move things around, divide by a negative again. So you notice the sign is flipping again. We get a new line. So I'm going to graph it. I put an intercept at -2. I go up 2 and over 5 to get my second point. This time it's equal to this number, so I'm going to put a solid line, but I'm looking for where y is less than or equal to. So the y values are less than the line underneath this one. So my zone is here. And I try 0, 0. Now, it's important to realize that 0, 0, according to what I've colored, is not in the solution zone. So I should be getting something that's false. I put in a 0 here and here, and I'll get 0 is less than or equal to 0 minus 2. So it's look like I'm saying 0 is less than or equal to -2, which is definitely false. So I have verified that this is not in the solution region. So my diagram looks fine. Now, this is the next part where we were looking at doing the very same thing, but now they're giving it to us in a separate notation. We took some time in class to talk about this notation. This notation is called set notation. It's like a very formalized way of describing the graph that you want someone to look at. You're going to see curly brackets at the beginning and the end in set notation. It always starts by giving you an ordered pair of x and y. And basically what it's saying is, I'm going to tell you something about an ordered pair in the Cartesian plane. At the very end, you'll see that it tells you that the x values are, in this case, real numbers. And that means that when I go to shade this one, I'm going to have to color it in. It's going to be solidly shaded. And then I have x minus 3 is greater than 0. So I think I've got a solution in the next one. That means that x is greater than 3. It's not equal to it. So when I draw the line for x is equal to 3, I'm going to use a dotted line right here. And then I have to show that the values where it's greater than that line are over here on the right-hand side. And you'll notice I shaded it. Okay, now the next one. This one is very similar. It's in set notation. You'll see the same kind of format to it at the beginning and the end, except take a look that it's actually using I, which means integers. Now, integers are negative and positive numbers, but they're not fractions and decimals. So when we go to try to graph this guy, we're going to have to use dots to be able to do it. So now we're going to take this equation and we need to move it around. And I think when I put the solution to this, I didn't show that necessarily. So let's just talk about it. You're going to move the y over. So it's negative 4y is greater than or equal to, and then the 9 goes over, negative 12. You're going to have to divide by negative 4. And when you do that, your sign is going to become less than. So you're going to have negative 4y is less than or equal to, well, actually, yeah, you're going to have y is less than or equal to, and it's going to be a 12 by the time you're done. And 12 divided by 3 is a 4. Mm, 12 divided by 4 is a 3. This is why usually I write down these guys, but I don't have it here. And so you'll just have to forgive me. It should be that you have y is less than or equal to 3 when you're done. So double check that to be sure. Now, when you go to create your graph, what you have to do is show each individual dot. Here it is that y is equal to 3 right here on the top. And so there will be nothing on the top. I kind of cut that graph off a little bit quickly. It was a really hard one to make because I had to form each one of these dots. But you'll see that you can put all the dots that are less than the y value. You can definitely see that. But these are only integers. So I don't use solid lines. I don't use shading. I have to use only the dots. Okay, I like these questions too. This is now when we flip it around, where I give you a picture and I ask you to create the graph. All right, and so I'm asking you actually in your homework to use set notation, and I believe these answers may not have the set notation. Let me just double check. Yeah, they don't. So what I'm showing is just the equation, and what I'll do is just describe to you what the set notation will look like. Okay, so look at this one and realize, okay, y-intercept of 2, a slope of 1 over 2. So it goes up 1 and over 2. So my equation is y is equal to the following line. I use equal because this is a solid line, but the region that is actually shaded is underneath. So I'm going to write that y is less than or equal to the following equation. So when you put it in set notation, you'll start with a curly bracket, and then in brackets, you'll put x comma y, the line that means such that, and then you're going to write your equation, this one, comma, and you will use that x is an element of the reals, comma, y is an element of the reals, and end it with a curly bracket. Next one, similar, except you can see that your equation now is simply going to be that y is equal to 1, that line. So mine is going to be y is greater than or equal to 1. And in set notation, curly bracket, in brackets, x comma y, a line such that y is greater than or equal to 1, comma, x is an element of the real numbers, and y is an element of the real numbers, end of the curly bracket. Okay, and then this one, we're looking at a new line. So now we have a y-intercept of negative 3, and it looks like our slope is down 2 and over 1 for this one. And so when we write it, we're going to have our y-intercept negative 3, our slope of negative 2, so we put in our equation. You can tell that it's not going to be equal to the actual line because of the dotted line. And then we're looking at all the y values that are smaller than this. So y is less than the line negative 2x minus 3. And again, put it in set notation, curly bracket in front, x comma y, such that y is less than negative 2x minus 3. And then you say that y is an element of the reals and, x is an element of the reals, and then y is an element of the reals. End of the curly bracket. Okay, now all this sort of algebraic background is in order to get you to be able to use these kinds of things in a real life problem. So we're going to do it piece by piece in the following example. Amir owns a health food store. He's making a mixture of nuts and raisins to sell in bulk. His supplier charges $25 a kilo for nuts and $8 a kilo for raisins. So the question is, suppose Amir wants to spend exactly $200 to make this mixture. Create an equation that represents his situation with your partner. So the first thing we did was we established, okay, the things that are changing are the kilograms of nuts and the kilograms of raisins. And I believe that the way we set it up was we said that we call this X for the nuts and this one Y for the raisins. So when you put it all together with the equation that they've given you, every time you buy a kilogram of nuts, you're going to be paying $25. And every time you buy a kilogram of raisins, you're going to be paying $8. And you want to know what will make it equal to $200. So there you have it. This is the translation. This is the mathematics translation. You've got a story and you're translating it into math. Now, to what set of numbers does the domain and range of the two variables belong? Are they real numbers? Are they integers? Are they whole numbers? Now, we discussed this quite a bit in class and just said, if they're real numbers, that means that we would be able to buy 1.5 kilos or 1.3 or 1.4. And certainly that kind of depends on what this supplier offers. He may only sell boxes in 1 kilo at a time. So it all depends. If he allows us, like a bulk store would, then definitely we could use real numbers. But keep in mind that if you're going to use real numbers, that you will not be able to use the negatives because there's no such thing as negative kilograms. Unless, of course, you had some teenager along for the ride who was eating your kilograms of nuts and they were disappearing. But in terms of what we're looking at, we really have to have, if we're going to use real numbers, they have to be larger than zero. Larger than zero and equal to zero, I suppose, could work. You could use integers, and that would be when the supplier is only going to sell you 1 kilo or 2 kilos. But again, you'd have to say that you're going to be from zero and higher so that you don't actually use the negatives. And if you're going to say that, then you might as well say that you're working with whole numbers. And so we decided the easiest one was to call them whole numbers. It doesn't mean that you couldn't call them real numbers as long as you simply said that they are greater than or equal to the zero, and as long as your supplier is actually letting you buy the nuts and the raisins in partial kilograms. Graph your equation. So we talked about, all right, how do we graph that equation that we created? And I did show you that the fastest way for you to do this, especially when the numbers start to get a little messier, is to use what we call the intercept method. So you look for the x-intercept and the y-intercept. And so you find that you have some values that you can put directly on your graph. You're going to have 8, 0, and you're going to have 0, 25. And so if you put that in place, then you get a graph that looks something like this one. Now, please notice, I guess I have used, assuming that my range and domain are real numbers because I'm using a solid line. Part of that is in order to create this graph for you online, it's just really, really tedious to do it if it's only integers. But here's my line, and you can see that none of them are going into the negative y's or the negative x's right now. So now, what region of the coordinate plane includes points representing the quantities of nuts and raisins that Amir could use if he wants to spend less than $200? So if he wants to spend less than $200, if we went back to this one, that means y is going to be underneath this one. And so when you do it, and I think I put it on there. Oh, okay, I still have the original graph. Then I think, yeah, there I did it. This shows us the region where all these individual dots that are all inside here give me possible solutions if he wants to spend less than $200. So then it says, what are 3 possible solutions? And so I picked a few of them. I found a couple, like you could use 0 and 10. So that would be 0 nuts and 10 kilos of raisins. Well, that kind of defeats the purpose because we do want it to be a mixture, but technically it is part of the solution. And then we had 5 and 2.5 as possible solutions, or 5 and 5. Any one of these points all along here could be used depending on what the supplier allows you to do. Okay, there you have it. You have been modeling linear inequalities, and you've begun to wrestle with the idea of solving problems. So take a look at your homework. It's listed online for you, and make sure you go through the process of checking your work and circling anything that really doesn't give you, that gives you a hard time. All right, good luck, everybody.